10,
let's go for main engine start.
6, 5, 4, 3, 2, 1, and booster ignition and liftoff of Space Shuttle Discovery, taking the space station to full power for full science.
Every civilization, from the first humans who carved constellations into the walls of caves to the engineers guiding modern spacecraft through the void, has asked the same question. How far can we travel? It is the question that humbles us, frightens us, and yet refuses to let us sleep. So before you get comfortable, take a moment to like the video and subscribe. But only if you genuinely enjoy what I do here, and tell me in the comments where you are and what time it is right now. I always find it fascinating to see our little community scattered across the globe. Now, dim the lights, maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. The moon was once a distant god. Mars was a red wanderer that mocked our ambition. And the stars, cold, distant, eternal, were the unreachable kingdom of the gods. But now, after centuries of dreaming, calculating, failing, and rising again, we live in the only era in human history where that ancient question can finally be answered with something more than myth. Because for the first time, we have machines beyond Earth, engines burning in the dark, signals crossing billions of kilometers. We have touched space, not with fantasy, but with metal, fuel, mathematics, and will. And yet, the truth is harsher than our dreams. Because when we ask, how far can we travel through space right now, we discover a reality that feels both triumphant and unbearably small. We can orbit Earth. We can reach the moon. We can send probes to Mars, Jupiter, Saturn. We can sling spacecraft past the edges of our solar system. But compared to the universe, compared to the gulf between stars, we have traveled nowhere. The cosmos stretches across distances so vast, so merciless, that even light, the fastest thing that has ever existed, takes years, decades, centuries just to cross the gaps between stars. And here we are, a young species standing on a dust speck planet, building ships that move like drifting embers compared to the blazing speed of light. But still, we push forward, because the question is not idle curiosity. It is the heartbeat of our destiny. How far can these fragile ships of metal take us? How far can we ride the thin engines we've built? How far can we reach with the physics we understand today? Not tomorrow, not someday, but right now. To answer that, we have to confront a sobering truth. Humanity has already traveled as far as our current technology allows, and the results are both awe-inspiring and painfully limited. Right now, our farthest ambassadors are not astronauts, not colonies, not grand starships, but small, aging probes launched decades ago by scientists who never expected them to last this long. Voyager 1, drifting through interstellar space. Voyager 2, following behind like a silent twin. Pioneer 10 and 11, faint signals fading into the dark. These are our footsteps in the cosmic sand, and they reveal just how immense the universe truly is. Because for all our brilliance, for all our rockets and equations and dreams, the farthest human-made object has not even crossed a single light day from Earth, and the nearest star sits more than 4 light years away. And yet, this is where our story begins. Not with what we hope to do, not with the technologies we might one day build, but with what we have now. The rockets we launch, the probes we send, the limits we cannot escape. Because only when we understand exactly how far we can travel today, can we understand what it will take to go farther tomorrow. And so the journey begins with truth, not fantasy, with machines, not myths, with the limits of our present, not the promises of our future. Every great journey begins not with a leap, but with a fragile, trembling step. And humanity's first steps into space were exactly that: fragile, trembling, miraculous. When we ask how far we can travel through space right now, We are really asking, how far have we already gone? And the answer is a story written in metal, fire, and silence. It begins in 1957 with a sphere no larger than a beach ball, a simple transmitter, a heartbeat in orbit. Sputnik. Its signal was weak. Its mission was simple, but it shattered the walls of the possible. Because in that moment, that single beep from the sky, humanity crossed a threshold older than civilization itself. For the first time, something built by human hands was no longer bound to Earth. Less than 5 years later, we followed it with something even more astonishing: a human being. Yuri Gagarin circled the Earth once. 90 minutes, a trip so short you could miss it during a long movie. But it changed the trajectory of our species, because the moment a human body survived the vacuum, the speed, the brutal physics of spaceflight, everything changed. The universe stopped being a distant dream and became a destination. But here's the truth that most people forget. Those early missions didn't take us far. Not compared to the cosmos. Not compared to the scale of everything beyond our sky. The International Space Station, humanity's home in orbit, floats just 400 kilometers above Earth. That's the distance between two cities, a road trip, a drive you could make before dinner. Our astronauts circle the planet at breathtaking speeds, but they are still pressed tightly against our cosmic shoreline. They see the curve of the Earth, the thin blue line of our atmosphere, the darkness beyond, but they do not travel into the deep. Not yet. So if we want to know how far we can travel right now, we have to leave the astronauts behind. Because the truth is brutal. Humans have only traveled as far as the moon, and we have not gone back in over 50 years. The entire human species, every one of us, has been no farther from Earth than a 3-day journey. 250,000 miles. A cosmic breath. Apollo was the spark. 12 humans leaving footprints in dust older than Earth itself. But once the flags faded and the missions ended, our reach froze. Humans stopped going farther. Our bodies never crossed that line again. And so the responsibility of pushing deeper into space fell to machines. Small machines. Quiet machines. Machines built not for glory, but for endurance. Voyager, Pioneer, New Horizons. These spacecraft are not heroic in the way astronauts are. They do not breathe. They do not see. They do not experience awe, but they do something no human can. They travel farther, longer, and faster than any living body could survive. New Horizons raced past Pluto at 14 kilometers per second, faster than any human has ever moved. Voyager 1 and 2 drift on momentum alone, crossing the invisible boundary where the sun's influence grows thin. Pioneer 10 was the first to escape the solar system entirely, its signal now barely a whisper in the cosmic dark. These machines, these metal seeds flung into the void, define the true extent of our reach today. Not dreams, not theories, reality. And reality is this: the farthest human-made object from Earth, Voyager 1, is still less than 1 light day away, and the nearest star, more than 2,500 light days distant. In cosmic terms, we have taken a step the size of a pebble toward an ocean larger than imagination. But there is something extraordinary hidden inside this humility. We have started. We are moving. We are learning how to survive beyond our world. Our early spacecraft are not failures. They are the first stones laid on a path no species has ever walked. They are the beginning of a bridge across the cosmos. A bridge built one probe at a time.
4,
Every probe
3,
we send,
2,
every human we launch, every rocket we ignite is dwarfed by a single truth.
Space Shuttle Discovery.
Space
Taking
is
the space
unimaginably,
station to full power for full
incomprehensibly
science.
vast. To understand how far we can travel right now, we must first understand the scale of the challenge. The solar system, vast as it seems on Earth, is just a pebble in the cosmic ocean. Distances that defy intuition stretch between planets, stars, and galaxies. Consider this: the Moon, a destination that once took humanity 500,000 miles, lies about 1.28 light seconds away. Mercury, Venus, Mars our neighbors in the cosmic neighborhood, lie minutes to tens of minutes away at light speed. Jupiter, the giant, is nearly 43 light minutes from Earth at its closest approach. Saturn, over 80 light minutes distant. Even the farthest planet we can send humans to today, Neptune, sits more than 4 light hours away. These numbers are not just abstract, they are reality baked into physics. Every second we delay, every limitation of fuel and life support compounds exponentially as we push outward. Our fastest spacecraft, New Horizons Voyager Parker Solar Probe, move at tens of kilometers per second. Incredible speeds by human standards, yes. But even at these velocities, reaching the nearest star would take tens of thousands of years. And then there are the stars. Alpha Centauri, our nearest stellar neighbor, sits over 4 light years away. That is roughly 25 trillion miles, a distance our fastest machines cannot hope to cross in a single human lifetime. Proxima Centauri, slightly closer, still requires over 70,000 years at our current top speeds. Every number reminds us of a humbling truth. Humanity's reach today is pitifully small compared to the immensity of the universe. Our rockets are powerful, our probes brilliant, yet the cosmos laughs at the scale we imagine. Distances that feel close in science fiction are, in reality, insurmountable with present technology. And yet, even within this stark truth, there is inspiration. The universe is vast, yes, but it is measurable. Every star, every planet, every parsec has a coordinate, a distance, a window into possibility. Our probes, our telescopes, our satellites are the first steps in translating that impossibility into achievable reality. Humans have always been defined by the distances we dare to cross. Once, crossing an ocean seemed insane. Once, walking from one continent to another was life-threatening. And now, the universe stretches before us in ways that seem unbridgeable. Our present reach is confined to our solar system and a handful of robotic ambassadors venturing into interstellar space, but even that is a triumph. Every light minute we cross, every signal we send, is a defiance of our biological limitations. Voyager 1, now over 23 billion kilometers from Earth, has entered interstellar space, carrying the golden record, a message to the cosmos, proof that we dare to reach farther than our planet allows. Yet, there is another reality that hits harder than any number. Our speed is the limiting factor. We are bound by chemical rockets, ion drives, and the laws of physics themselves. Acceleration is limited, fuel is finite, lifespans are short. Radiation and cosmic hazards threaten even robotic travelers. The distance we can traverse is not just a question of engineering. It is a question of endurance, of survival, of the human mind and human ambition confronting the infinite. And that is the paradox. The universe is vast beyond comprehension, yet entirely knowable. Its scale is daunting, yet measurable. It terrifies us, yet it beckons us. Every civilization has dreamed of flying faster, reaching farther, bending the rules of nature to satisfy ambition. And every physicist, every engineer, every dreamer knows the ultimate truth. The universe has a speed limit. Light, the very thing that illuminates our world, that carries the sun's warmth to our eyes, that travels across billions of miles in a single second, is untouchable. Nothing with mass can reach it. Nothing with mass can exceed it. And yet it defines everything we can hope to achieve. When we ask how far we can travel through space right now, the answer is inseparable from this speed limit. Chemical rockets, ion drives, and even experimental propulsion cannot come close to the velocity of light. Voyager 1, humanity's fastest traveler, moves at just 17 kilometers per second, a staggering achievement, yet only 0.0057% the speed of light. At that pace, Alpha Centauri would remain over 75,000 years away. Even hypothetical nuclear propulsion, the stuff of decades of research and science fiction, would still take centuries to reach the nearest star. And proposals for antimatter engines or light sails, bold, ambitious, almost magical in concept, remain firmly in the experimental realm. Reality in 2025 is humble. We cannot touch light speed. We cannot cross the stars in a human lifetime. We are bound by our technology, by physics, and by patience. And yet, the speed limit teaches a deeper lesson. It is not just a constraint. It is a mirror reflecting humanity's limitations and possibilities. Every fraction of acceleration we gain, every incremental improvement in propulsion, every kilogram of fuel carefully optimized, is a negotiation with the universe itself. The faster we go, the farther we can reach, but even that distance is dwarfed by the cosmic expanse. Time, too, becomes a factor. At speeds far below light, years for the traveler means centuries for those left behind. Even with theoretical near-light speed travel, relativistic effects would allow a traveler to experience months or years, while decades or centuries pass on Earth. Today, with our machines crawling at tiny fractions of light speed, this effect is negligible, but the implication is clear. Our present travel is slow not just in distance, but in consequence. Generations pass before we reach even the nearest destinations. Radiation, collisions with interstellar dust, and navigation errors are amplified at higher velocities. Every small hazard becomes catastrophic when your craft moves faster. The universe imposes its speed limit not only on distance, but on survival. To push harder, we must engineer smarter, shield better, and plan longer than humanity has ever done before. And yet, this speed limit does not diminish ambition. It focuses it. It clarifies what is possible now, what must be pursued later, and what will require ingenuity beyond imagination. Every spacecraft we launch, every probe we send, every observation we make is measured against this cosmic law. In the end, the speed of light is a reminder. We are creatures of patience as well as ambition. Our reach today is limited, yes, but it is real, measurable, and remarkable. We may not touch the stars in a human lifetime, but we can send our messages, our machines, our dreams ahead of us. Every journey into space, every probe hurled into the void, every astronaut lifted beyond the cradle of Earth is powered by one undeniable truth. We move only as fast as our engines allow. When we ask how far humanity can travel through space right now, we must start with the machines that make motion possible. And the truth is both humbling and inspiring. Our rockets are feats of precision engineering, but they are bound by the limits of chemistry, fuel, and physics. The Saturn V, the legendary rocket that carried Apollo astronauts to the moon, could accelerate humans beyond the atmosphere and across 384,000 kilometers of space in mere days. Its power was unimaginable to earlier generations, yet compared to interstellar distances, it is a spark in the dark. Voyager 1 and 2, propelled by chemical rockets and assisted by gravitational slingshots, move at tens of kilometers per second, astonishing by human standards, yet almost frozen when measured against light years. And then came ion drives, engines that whisper in the void. Small, efficient, slow to start, but relentless. They sacrifice brute force for endurance. Missions like NASA's Dawn spacecraft, propelled by ion engines, demonstrated that with patience, a spacecraft can traverse vast distances, entering and exiting the gravity wells of multiple planets. The distance covered is modest by interstellar measures, but the principle is profound. Speed is not always about power. Sometimes it is about persistence. Gravity assists to extend our reach. By slingshotting past planets, spacecraft can steal momentum from giant worlds, increasing speed without burning extra fuel. This elegant dance with celestial mechanics allows us to go farther than our engines alone would permit. Without it, our probes would be trapped in the solar neighborhood. With it, we reach the outer planets, the Kuiper Belt, and eventually interstellar space. But despite all ingenuity, there are hard limits. Fuel is finite. Life support for humans is fragile. Every kilogram added to a spacecraft increases the cost and reduces efficiency. Radiation in space is relentless. Cosmic debris moves like invisible bullets. Even if our engines could accelerate us to a fraction of light speed, the journey becomes a hazard-filled gauntlet. In short, our technology today can reach the Moon, Mars, and the outer planets. It can send robotic emissaries across the solar system. It can, with patience, cross the heliosphere and enter interstellar space. But the stars, the nearest suns beyond our own, remain completely beyond our grasp. The distance is immense, the timescales enormous, and our current engines insufficient to bridge the cosmic gulf in a human lifetime. Yet, even within this constraint lies triumph. We have sent our machines farther than any other species could imagine. We have mapped planets, traversed asteroid belts, and glimpsed distant dwarf worlds. Our reach is small on a cosmic scale, yes, but it is real, tangible, and expanding. Every probe, every launch, is a step into the void, proof that humanity refuses to remain on a single planet. Every journey through space is not just a test of engines or fuel. When we ask how far humanity can travel through space right now, we must confront the most sobering truth of all. The universe is measured not in kilometers, but in years, decades, and millennia. Consider our fastest spacecraft, Voyager 1. Launched in 1977, it now drifts beyond the heliosphere, the bubble of the sun's influence. It has traveled over 23 billion kilometers. That is astonishing, a testament to human ingenuity, patience, and perseverance. And yet, even at this incredible distance, Voyager 1 has not left the immediate neighborhood of our solar system in any meaningful sense. The nearest star, Proxima Centauri, is over 40 trillion kilometers away. At Voyager's speed, it would take more than 70,000 years to reach it. 70,000 years. Longer than human civilization has existed. Longer than any written history, any empire, any city. To our tiny human lifespans, this is unimaginable. Even our fastest probes move at velocities so puny compared to light that interstellar travel remains a dream, a calculation, a fantasy. What about human travel? Apollo astronauts reached the Moon in 3 days. Mars, with current technology, would take 6 to 9 months one way, assuming optimal conditions. Even this short journey strains the limits of life support, psychological endurance, and radiation shielding. Extending that to the outer planets is possible, barely, but moving beyond the sun's influence with humans on board is completely beyond our present capability. Time becomes the ultimate tyrant in space. Distances that seem enormous on Earth, thousands of kilometers, are trivial. Distances between stars are measured in light years, and every light year stretches across nearly 10 trillion kilometers. Our fastest technology moves too slowly to cross them meaningfully. And yet, paradoxically, this limitation sharpens our ambition. By confronting the tyranny of years, we learn the value of patience, persistence, and preparation. Robotic probes become our eyes and ambassadors. Each probe, each mission, is a calculation in patience, a dialogue with time itself. Even theoretical near-light-speed travel illustrates the harsh truth. Unless we can radically change propulsion, generations would pass on Earth before travelers arrive at their destinations. Civilization itself must adapt to timescales far beyond individual lifespans, planning and sustaining missions across centuries, millennia, or even longer. The universe is vast. The distances are cruel. And yet, humanity has already begun the journey, slow as it is, measured, deliberate, and daring. Every human who dreams of space travel must confront a brutal truth. The universe is not designed for us. Earth is our cradle, a delicate haven with gravity, atmosphere, and magnetic fields shielding us from the void. Beyond it, the cosmos is indifferent, lethal, silent, and unyielding. When we ask how far humanity can travel through space right now, the answer is constrained not only by engines or fuel, but by the fragility of life itself. Every day in space carries risks that Earth-bound humans rarely imagine. Radiation from the sun, cosmic rays from distant supernova, and micrometeoroids traveling at tens of kilometers per second all pose threats that grow exponentially with distance and time. On Earth, we are protected. In space, we are exposed. Life support is another unforgiving limitation. Humans need oxygen, water, food, temperature regulation, and waste management. Every kilogram counts. Every malfunction can become catastrophic. For short missions, like the ISS orbiting just 400 kilometers above Earth, redundancy and resupply are possible. For journeys to Mars or the outer planets, every system must function perfectly for months or years without fail. Psychological endurance is equally critical. Humans are social creatures. Isolation, confinement, and the relentless blackness outside a spacecraft challenge mental resilience. Even astronauts on the ISS experience stress, disrupted sleep, and the strain of living in a metal tube suspended over Earth. Extend that to missions spanning months or decades, and survival is as much a matter of the mind as of engineering. Radiation is perhaps the most insidious hazard. Cosmic rays can damage DNA, increase cancer risk, and impair the nervous system. Without the protective magnetosphere of Earth, astronauts are exposed to a constant barrage. Shielding is heavy and costly, and current technology can only mitigate so much. For interstellar distances, radiation alone would make human survival extremely challenging, without breakthroughs we do not yet possess. And yet, despite these constraints, humanity pushes forward. NASA, ESA, and private ventures are testing technologies for long-duration spaceflight, artificial gravity, advanced shielding, regenerative life support, and psychological support systems. The dream of traveling beyond Mars is not impossible, but it is exponentially harder than sending machines. This fragility of life defines our reach today. Machines can drift for decades, slowly but persistently crossing vast distances. Humans, by contrast, are tethered to the limits of biology. We can touch the moon. We can orbit Earth. We may reach Mars with careful planning. Beyond that, every kilometer adds risk. Every month compounds danger. The lesson is stark. Our reach into space today is as much about surviving as it is about traveling. Engines and speed are meaningless if life cannot endure the journey. And this reality shapes every mission, every calculation, and every dream of venturing farther than we have ever gone. Every dream of human expansion into space is mirrored by the quiet achievements of our robotic pioneers. When we ask how far we can travel through space right now, the answer is found not in the astronauts orbiting Earth or the rovers crawling across Mars, but in the silent, tireless machines drifting into the cosmic dark. Voyager 1, Voyager 2, Pioneer 10, Pioneer 11, and New Horizons. These are humanity's first true travelers, and they carry more than instruments. They carry our ambition, our curiosity, even our messages to the stars. The golden records aboard the Voyagers are capsules of culture, music, and greetings, a testament to our species' desire to reach farther than our bodies can go. These machines move slowly compared to the speed of light, but in the vastness of space, slow is relative. Voyager 1, over 23 billion kilometers from Earth, has entered interstellar space, the region between stars where the sun's influence fades into the galaxy. It will continue drifting, silent and persistent, for thousands, perhaps millions of years. Long after humans are gone, these metal travelers will carry proof that a species once reached beyond its home planet, and yet their journey is a reminder of our limitations. Even Voyager 1, humanity's farthest emissary, would take more than 70,000 years to reach the nearest star at its current speed. Our probes are fast enough to leave the solar system, but not fast enough to bridge interstellar distances in any meaningful human timeframe. They are ambassadors of patience, carrying the torch of exploration at a crawl measured against the cosmos. New Horizons, which flew past Pluto in 2015 and now continues toward the Kuiper Belt, demonstrates another truth. Progress is incremental. Every probe builds on the lessons of the last. Every launch pushes farther than before, mapping our neighborhood, measuring cosmic rays, photographing distant worlds. We are learning to traverse the void, step by step, probe by probe. Even Pioneer 10, launched in 1972, is now a ghostly traveler, its signal faint, almost gone, yet still moving outward. These machines illustrate the most essential reality of our current reach. We can send objects far, but we cannot yet send humans to the same distances. The silent voyagers also reveal the scale of ambition versus capability. They teach us patience, precision, and the need to respect time. Distances in space are not measured in days or months, but in decades, centuries, and millennia. Every signal, every data packet from these machines reminds us of how small humanity's footprint is in the vast cosmic ocean. And yet, this is where hope and reality meet. While we cannot yet traverse the stars ourselves, these machines prove that traverse we can, incrementally, deliberately, and with care. They are the blueprint, the first steps toward a future where humanity may follow. Every human being who looks up at the night sky has felt it. The longing to go farther, to cross the distance between stars, to step into worlds that no one has ever touched. It is the same longing that drove the first sailors to leave the shore, that pushed Apollo astronauts to the moon, and that fuels every mission we launch today. But when we ask how far humanity can travel through space right now, the answer is brutally clear. We cannot reach another star. Not yet. Not with the technology we possess. The nearest star system, Alpha Centauri, is more than 4 light-years away, over 40 trillion kilometers. At the speed of Voyager 1, it would take over 70,000 years to arrive. Even the fastest proposed human missions, using nuclear propulsion or ion drives, might reduce that time to hundreds of years, still far beyond a human lifetime. For a crewed interstellar mission, we would need technology that does not yet exist. Engines that produce constant acceleration, shielding capable of withstanding decades of radiation, life support systems that can function autonomously for generations. And the challenges are not only technological. Biological limitations loom over every calculation. Humans age, bodies deteriorate, minds strain under isolation and confinement. Even if we could design ships that travel near the speed of light, the crew would experience relativistic time differently from Earth, returning to a world changed by centuries or millennia. Generational ships, where multiple generations live and die during the journey, are a theoretical possibility, but the social, psychological, and ethical challenges are staggering. Energy is another insurmountable barrier with current capabilities. To accelerate a spacecraft to a significant fraction of light speed requires unimaginable amounts of fuel and propulsion efficiency. The tiniest miscalculation could doom a mission before it even leaves the solar system. Even small collisions with interstellar dust become catastrophic at these velocities, capable of tearing apart entire ships. And yet, despite these overwhelming obstacles, the dream persists. Humanity's imagination is not limited by physics. Our ambition stretches beyond it. Projects like Breakthrough Starshot, tiny, unmanned spacecraft accelerated by powerful lasers toward Alpha Centauri, hint at what might be possible, but these are still experiments, not solutions. We are not there yet. We are explorers at the edge of feasibility, standing on the shores of the cosmic ocean, our gaze fixed on distant lands we cannot yet touch. This reality frames the paradox of our time. We can send probes farther than ever before, but humans remain tethered to Earth. Our reach is vast in ambition, but still confined in execution. And yet, it is precisely this paradox that defines humanity. Our species dreams in scales far beyond our immediate capacity. We are limited, fragile, slow, and yet unyielding. The universe is indifferent, but we persist. Every civilization, from the first humans who watch the stars shimmer over untamed landscapes to modern engineers crafting spacecraft, has been defined by one relentless drive: the desire to reach beyond the known. And when we ask how far we can travel through space right now, the answer is both sobering and inspiring. We have traveled farther than any species in history, yet the stars themselves remain beyond our grasp. Our reach today is confined to the solar system and the early whispers of interstellar space. Our farthest machines, Voyager 1, Voyager 2, New Horizons, drift silently into the void, testaments to human curiosity and patience. They reveal the harsh truth. Even with our most advanced technology, distances measured in light years remain impossible for humans to traverse. Yet, within that limitation lies a profound lesson. Humanity's ability to explore is not measured solely by physical travel. It is measured by knowledge, ambition, and ingenuity. Our telescopes probe galaxies millions of light years away. Our robotic explorers map planets, asteroids, and moons. Even if we cannot yet walk among the stars, we can see them, understand them, and prepare for the day when reaching them becomes possible. Our present limitations teach us patience. They teach us to innovate incrementally. Every rocket, every probe, every mission beyond Earth is a step toward mastery of the cosmos. We are learning not just to survive in space, but to navigate, endure, and thrive in environments that were once utterly hostile. These lessons, in engineering, biology, propulsion, and perseverance, will define the moment humanity finally crosses the barrier to interstellar travel. And the paradox is beautiful. The universe is vast, indifferent, and relentless, yet it beckons. Our reach is small, our engines slow, our lifespans brief. But our imagination, our ambition, and our ingenuity stretch across the void. Today, our steps are tiny, measured in kilometers and billions of kilometers. Tomorrow, they may span light years. So, when we measure how far humanity can travel through space right now, the answer is clear. We are explorers at the edge of our solar system, observers of the stars, and creators of dreams that will one day carry us farther than our ancestors ever imagined. The journey is not over. It has only just begun. Every probe we launch, every plan we conceive, every insight we gain pushes the horizon farther away and closer at the same time. Humanity may not touch another star today, but the reach of our ambition is already there, waiting for the technology, the courage, and the persistence to catch up. And so the journey ends, for now. We have seen how far humanity can reach today, the fragile metal of our spacecraft, the fleeting footsteps of astronauts in orbit and on the moon, and the silent, tireless probes drifting into interstellar space.